And we're live. Welcome, everybody. We are going to be chatting with Usama Fayyad. I've been looking forward to this for quite some time. Usama is well known for a number of things, one of which is being the first chief data officer when he was at Yahoo, which is a story that he's often asked to tell. And I am Keith McCormick from Cloud Factory, and we are basically a human-in-the-loop oriented company. Creating meaningful work for people in developing countries along with that mission. So I want to thank Usama for being here. And the way we're going to structure this is he and I have a lot to talk about. So that will take the first 30 or 40 minutes. And then we will take questions. We're setting aside 20 minutes for that. We really enjoy the question part of the show. And I want to thank my colleagues who are monitoring the chat. You know, in StreamYard, we're on multiple platforms. So if you want to just kind of announce that you're here and so on, you can interact with them and they'll feed that information to me. And they'll also be gathering the questions. So you can start asking questions right away, even though we won't really turn our attention to that until about 30 or 40 minutes from now. So Usama, again, a ton of things I want to talk to you about. You know, the audience might not know, we know each other from a couple of KDD events. I attended a great workshop that you did in Anchorage a couple of years ago. And then I collaborated on the one that you did with iAds last year. But I'm super excited to talk to you about your new role as Inaugural Director at Northeastern. So when I first encountered that program, you know, I was noticing that it looked like you were attracting, you know, postdocs, but I guess it's a real a mix. We'll get to that in a moment. But I wanted to ask you to comment a little bit on the name, this notion of experiential AI. Of course, at Cloud Factory, we're super focused on human in the loop, and there's some overlap there. You know, there's some Venn diagram that would show a little bit of an overlap between what you mean by that and human in the loop. I was hoping that maybe we could start with that topic.
Yeah, thank you, Keith, and it's great to be here. So let me start by saying the Institute for Experiential AI has that unique name, and nobody understands what experiential AI is, and we often have to explain what we mean by it. So first of all, it's more than a kind of Venn diagram. It's a very big intersection between human in the loop and experiential AI. However, I'll add a slight variation to it. So experiential AI to us means human-centric AI, i.e., you know, the truth is out there, and you know it very well. There is no general AI. There is no autonomous AI. AI algorithms are weak at best. We haven't progressed much in terms of the sophistication of the algorithms. However, what has happened in the world is you get a lot more data, and hence kind of your big theme on human in the loop, because that data is not useful until it is labeled reliably and utilized in machine learning to kind of figure out what the solution to the problem should be from an input-output perspective. Can we emulate what a human does? To me, human-centric AI goes slightly above that. It's a big part of it is a human in the loop to make sure that the AI is successful. But in our case, we generalize it to both not just generating the data needed to reliably understand the phenomenon and label it correctly so that the machine learning algorithms can operate correctly. However, it is also about intervention. It is also about the fact that these algorithms often kind of go awry. The minute they see something they haven't seen before, has not been pre-labeled for them, who knows what they predict? And most of them predict nonsense. So knowing that the algorithm is in a bad zone and needs an intervention is a key issue. Figuring out how that intervention happens naturally, efficiently, you know, how do you effectively teleport a human in to a situation? How do you explain the context to them? How do they give you the most information with the most minimum effort? And how do you make sure that the input they give you in that intervention is correct and useful? So to me, it's really about human-centered AI. To me, AI is really about not replacing the human with a robot. It's really about extending human capabilities, amplifying them in areas where humans are just naturally weak, and leveraging the natural strengths of the humans that we haven't been able to this day emulate in machines, which is common sense reasoning, kind of decision making under uncertainty, utilizing what we call the gut feel. None of those we even approached coming close to. And an algorithm doesn't know when it's doing something silly. When a child looks at its behavior and says, hey, this is silly, right? We don't know how to replicate that in a machine. And to me, that is experiential AI, which has to do with how do you use that AI and how do you apply it in the real world to real problems and help kind of the process of advancing the AI and the human AI interaction.
Yeah, no, that makes a lot of sense. I have a follow-up question, but I want to mention to the audience as well as you what folks said in the poll. We had a poll out on LinkedIn for a couple of weeks, and what was interesting is how dramatic the answers were. So we offered up the topic that we just talked about, actually, explaining the difference between experiential AI and human in the loop, future of autonomous vehicles, deep learning and data science careers. And I bet you can guess the winner, but what surprised me was the amount that it won by. Data science careers got 44%, but it could be partly the LinkedIn, audience. So I wanted to ask a question that kind of ties into that. When I first encountered the announcement that you were going to be inaugural director of that program, I noticed that there were advertising for postdocs and so on. But I guess you're attracting a real mix of folks. Who are you trying to attract to the program? What are kind of some goals of the program? But I'm curious about what backgrounds they all have and what areas they're interested in. What draws them to that program?
Yeah, I think the university started out before my arrival by emphasizing at least hiring postdocs in the area that I outlined in what was defined kind of very fuzzily as experiential AI at the time. After coming on board and working with the leadership of the university and with many of the faculty and the researchers there, we kind of homed in on what we want to do with the institute. So my mission as the inaugural executive director is to really create the top institute in the world when it comes to experiential AI, i.e. AI, human-centered AI with the human in the loop being a core part of it. So how do you do that, right? And the way we chose to do that is to basically say, look, we are going to keep it very experiential, meaning we are going to work with companies, with government, with organizations, and with public data sets on actually solving problems. So we are creating what we're calling the AI Solutions Factory. And this is going to relate to data science in a huge way in a second. That AI Solutions Factory, its job is to deliver solutions. So it takes on projects, it delivers on the projects, real deliverables with real data, real problems, real issues, real missing stuff, real too bad, I can't help you figure out what the system should do in this case, which is what we face in reality. And in doing that, we're generating economic value, but we're also detecting and finding problems that need research. I'm a strong believer, and we did this at Yahoo Research as an ethos when we created Yahoo Research, is I used to say, and I still maintain it, the most interesting theoretical problems are often embedded in the most mundane of applications. Getting something to work actually has you tackling and solving deep research issues that can be foundational and actually field changing in general. And we did this in economics and in areas of algorithmic marketing and algorithmic advertising at Yahoo. But what I would say here is we plug in, we kind of have a workforce that's working on delivering these solutions. I don't expect professors to be delivering these. We are actually hiring data scientists, professional data engineers, programmers, and these are going to be operating the solutions factory, the AI solutions factory, where the faculty and the research staff and the postdocs come in is to kind of deal with the harder issues. So to make it unique, we kind of uniquely overlay it with deep know-how in certain areas that very few know how to address. And the job there is to pick out the interesting research problems. Now, to top it all off, and this is the experiential part that's most interesting, is as we both know, and as you know well, data science, everybody wants to be a data scientist. And today, your qualification to be a data scientist is, okay, let's just change my title on LinkedIn. I'm now a data scientist. Why? Because nobody has standards and definitions of what makes a data scientist. What should they know? What do I expect them to do? So employers are confused. Honestly, candidates are confused, and educational institutions are confused. However, one of the conclusions we reached, especially from the last workshop that we did online at KDD and you attended, was that a missing ingredient in the education of data scientists is having that apprenticeship-based learning. Right, that ability, and especially a supervised apprenticeship. So normally a data scientist graduates with some knowledge of algorithms, machine learning, etc. And they, I'm sorry, this is, I gotta. They basically have to learn on the job, and when they learn on their own, God knows what they learn, and they often are never fortunate enough to have a somebody who would give them that supervised kind of advice and mentorship, what we call apprenticeship. So what we're doing is we're utilizing that operation of the AI Solutions Factory to basically create courses, to create a learning program, which is very much like the residency program in a medical degree, where you go to a teaching hospital and you kind of learn by solving and working with surgeons who know what they're doing and people who give you advice. So that is exactly what we're doing. And that requires kind of a whole teaching staff side of it that we're also hiring. There's a huge investment by the university in this. And many of our partners, companies, government agencies, etc., that we talk to about this are super excited by the model. It is unique. And I actually am super excited by it because it will provide the first example of an apprenticeship-based learning experience, a true residency program that produces data scientists who not only understand the theoretical aspects, but actually are ready to be productive day one and have gleaned some of that art of data science versus just the science of data science, which then allows them to be effective at their job. Yep. As an employer of data scientists, I could tell you, any graduate of higher ed, fresh grad, first 2 to 3 years, they are not that useful because they think it's all about hacking at data with an algorithm, when in reality, it's really about understanding the limitations and really naivete of the algorithms and understanding the huge dependence on data representation, quality of data, all of that. And that appreciation will happen when you actually solve real problems in real situations, delivering real deliverables.
That medical residency metaphor is so powerful to me. It reminds me of a comment that Robert Monarch made last month. He's written a book, for Human in the Loop, and in running large projects, where tens or hundreds of thousands of cases have to be labeled. And he was talking about a particular experience that he had with a automobile manufacturer that had to go through that process. And they hired, I think it was 6 or 8 data science PhDs, but there wasn't a lot of data annotation or project management experience among them. And they ran into so much trouble after 6 months that they had to, the way he told the story, they had to literally start from scratch. So I'm guessing from what you just said that clearly resonates with your experience. But could you comment a little bit on some of the skills that you find that even at that level, I mean, even someone that spent, nearly a decade with classroom instruction and the algorithms, and I know you and I both feel strongly about statistics, that should make at least a brief appearance in the classroom instruction. There should be a little bit of statistics snuck in there. What skills do you find that even at that level are lacking without that hands-on residency experience?
So the skills that are lacking are really in the area of the art of data science, meaning an appreciation of the limitations and let's put it bluntly, the stupidity of the algorithms, right? If I feed the algorithms data that is biased in any way, data that is not representative of reality, the algorithm will eagerly and readily start predicting junk and start repeating junk, right? So the trick there is to have people who are trained in the art of understanding that they are dealing with these fairly stupid algorithms, trying to make them work. Now, these algorithms can be very powerful with the right context and with the right training data and the right quality. They can do amazing things that look like magic. And I've been privileged in my life to participate in several projects that, you look at it and you say, how the heck is this happening? And how could this, magic box do things that humans can't do? However, the real part of the story is 99.9% or more of the applications involve the other side, the side where the algorithm is doing really stupid things. And it's because the training that the data scientists or the machine learning experts, etc., have had is really around kind of understanding algorithms. Understanding algorithms doesn't teach you about all the vagaries and weird stuff you see in data. Doesn't teach you the fact that these algorithms are so naive that you have to like massage and represent the data in so many different ways for them until they finally get it, right? And that is the part that's missing. Now, related to this also is the fact that data scientists themselves and machine learning folks, that, while they're good at the algorithms, they are not good at doing things like labeling data, at judging whether something was labeled right or wrong. That's a whole other different set of skills, and that's typically missing, right? So you feed it to somebody. If they don't have that judgment, they can't even tell you whether these labels are reliable, high quality, to be trusted, to be mistrusted, to be inverted. You absolutely need that domain knowledge, and you absolutely need a different set of skills to do that.
Yeah, and it's another thing that you mentioned that's really powerful, is the bias, because, as somebody that spent countless hours wrestling with these algorithms when they're not cooperating, right? When their stupidness is coming through and they're just being stubborn, is that bias can't be corrected very easily at all on the algorithmic level. You could try to weight things, or it just seems like a fool's errand to, even try. It's really, if the bias is in the data, then it's going to perpetuate itself through the additional, phases. I want to briefly kind of call a shout out, because the international nature of Cloud Factory and of our audience is really coming through. We have Christine joining from Florida. Nanette, I think I might recognize the Nanette that is from Raleigh. We have folks joining from Nepal, Summit, and Kelvin joining from Nairobi, and a number of others. For those of you that don't know, Cloud Factory has offices in both Nepal and Kenya, so we tend to attract this really broad international audience. So I wanted to follow up on what we were just talking about, but something in particular strikes me as interesting. So you've described what you're trying to do as a solutions factory, and you talked about human-centric. So I want to circle back to that a little bit. What are some of the strategies that you foresee to get humans and the algorithms to work together in near real time? So one of the classic examples that people have been talking about lately is radiology and all the progress that the algorithms have made there. But then there has to be, perhaps the algorithm is ranking the cases that then a human radiologist looks at. And then one thing as a modeler that I worry about is, how is the informal feedback of that radiologist getting back into the data? Because if it's only a one-way street, then the model will never. It's a big topic, but I would just love to have you talk about that a little bit, because that's probably the piece, especially if if they've done things like Kaggle competitions, you don't get that feedback loop experience with that. What are some strategies to get the human and the algorithm working in both directions?
And that is, by the way, one of the secrets of the true power of the human in the loop. It's not just the labeler in the loop. It's actually also the expert in the loop who's actually giving feedback as to what is good and what is bad. By the way, not very well known kind of secret out there. Search engines, everybody uses the Google search engine and other search engines. They rely at their heart on this kind of loop, where there's continuous feedback that basically says these search results are wrong. move this up, move this down, eliminate this, etc. And that's actually human feedback, editorial feedback by tens of thousands of real people looking at it. Talking about radiology, right? An example of this, to me, the power of that example is great, because the first thing that happened in the US was people figured, hey, let's centralize radiology reading, right? Let's hire a whole bunch of radiologists, like in a big cluster. There's a famous one outside Denver, Colorado, but let's put them together, right? Then people started realizing, and then any X-ray you take digitally gets transmitted there. A human radiologist looks at it, gives you the readout, their interpretation, and then, of course, the physician locally will look at that readout and communicate it to the patient or make a decision for treatment. Then people realized, hey, we've got data here. We've got labeled data. We've got radiology images. We've got the readout given by the expert radiologist. Can we now start mapping these automatically? And to me, this is a great example of something that you should not fully automate, right? So what happens here is you can take a reading of an X-ray from being, I don't know, 5 to 10 minute task between reading it and reporting on it, to saying, okay, I use algorithms to learn from this vast amount of data that I collected over the years and try to basically identify regions of interest in the image and then guess what might be a good readout report to give. However, I emphasize might be, right? You still need the human to look at it. But that human now can very quickly verify, hey, the machine is right, or can very quickly detect, hey, the machine is off. It really missed this whole other area, or this readout doesn't make sense in this particular case because of this exception. That bit of feedback is essential in two ways. One is guaranteeing the quality, so nothing goes back to the physician or the provider's office without having been filtered through the human expert eyes, which is a must. But number two, and this is what you allude to, which is a gold mine. Collecting that feedback is the best way, we call it relevance feedback in the literature, is the best way to kind of provide feedback to adjust what the algorithm is doing and make the algorithm smarter, right? So that human in the loop there is essential. And that's a beautiful example of doing what a machine does best. The machine doesn't get tired. It will stare at 10,000 images, and it will consistently, always, reliably find these weird things. But the machine doesn't have the knowledge that a radiologist has, so it will miss things. It will misdiagnose things. It will not have coverage of certain things, and that's where the human comes in and says, okay, wait a second, you did a good job here, but you missed this one, right? And then the next time the machine does it, it has a bit more information. And as that builds over time, it becomes a true gold mine in terms of coming up with something that's totally reliable. Now, there's a lot of temptation. This happens in banking. Once something works with very, very little feedback needed, you say, I'm going to do an STP, a straight-through processing, meaning no human checks it. That may work if you're automating kind of, document processing in a bank. And it may work very well if you're doing advertising where an error is okay. I find it very difficult to accept it completely when you're doing diagnosis that involves human lives and human health. So having that human in the loop, double checking it, is always useful, both from a quality assurance, but also from ensuring that the machine is getting better, not worse.
I have lots of follow-up questions that I want to ask, but there's one that I'm particularly focused on. You can think about the level of expertise in that data annotator, that we were just talking about. Like you were talking about the near the end of the cycle where the expert, there was a lengthy article actually in the New Yorker about what you were just describing. That one of the things that was fascinating is that one thing that the human doctor would do that the algorithm wouldn't do is say, well, I don't think you have skin cancer, but you look kind of jaundiced. I want to run these other tests on you, right? So that's something a human doctor will say, is that you won't trigger the diagnosis that was being looked for, but something else. So there's clearly a role for the expert in the loop. But something that I encountered when I was first really getting to know Cloud Factory that I found absolutely fascinating, that I would love to have you comment on, is that when you're trying to create these very large annotation data sets, you very frequently have a task that's more complicated than you can do with, let's say, 15 minutes of instruction. You need more expertise than that. But then if you're going to try to look at ag tech data, for instance, and you are trying to get a bunch of PhDs in agronomy, well, there's only so many of them to go around, and their bandwidth is going to be limited. And sometimes what happens is if you get somebody that's been well trained but is not an expert, but is going to spend a year on that task, they develop an expertise that somebody that, let's say, is a grad student that's only made themselves available to a project for a couple of weeks and that isn't particularly focused on that task doesn't have. How would you, if you were managing a large data annotation project, how would you go through the process of trying to figure out when you need that kind of high-level expertise like an MD, and when there's a certain expertise that comes from the task itself? It's kind of an interesting distinction.
Yeah, I mean, and this is very interesting. So this will vary. There's a spectrum of tasks where you absolutely need a real expert to be looking at it, to interpret it, all the way to tasks where, in fact, you prefer non-experts to be looking at it. So let me give an example, and most tasks are somewhere in between, right? So here's what I mean by that. Experts, by their nature, are very, very biased, right? When you kind of spent a lifetime looking at data in a certain way, you're going to develop your own biases, and you will blind yourself to many other things that are not there because you're looking at certain things, and you may be dismissive of other things very quickly. Whereas if you teach a human who's not such an and humans are great learning machines. They are, to this day, better than most machines at learning. The human always brings that fresh perspective. Like the human visual system, especially on the vision side, has amazing capabilities. And by the way, let there be no confusion. We don't have machine vision algorithms and image understanding algorithms that even match what our human visual processing system can do in terms of understanding and interpreting. It's really a very challenging, a grand challenge problem that hasn't been solved for the past 60, 70 years. So here's what happens. You bring in somebody new who has their own smarts and their own way of looking at stuff, and they will notice some of the things that an expert may not notice. They will actually look at it with fresh eyes, basically, and say, yep, I see the pattern you trained me on, but I see this other thing that looks weird, right? And an expert usually is so expert that they always home in on the zone that they want to look at, and they may miss something peripheral or adjacent or a bit far in the image, whereas fresh eyes would actually detect it. And when they ask that question and get the feedback, that's another opportunity to capture more data that is invaluable, right? And that's an example of the kinds of stuff that you can only get experientially, right? Through doing this right and capturing the right data. You would never capture that. So, for example, I could tell you, if we take it all the way to the other extreme where you prefer non-experts, right? Search relevance feedback, I alluded to, right? You'd rather have normal human beings, consumers, look at it and give you the feedback, because the expert will tend to kind of be too understanding, if you will, or too accommodating of the algorithm. Oh, I get why they got this result back, right? Forget it. That's not the consumer experience that's going to happen, right? You want the feedback that says, this doesn't make any sense to me, and this is absolutely wrong, or this is offensive, or this is whatever. That's number one. If you take it all the way to driving, to autonomous driving, for example, you got a lot of human labelers who are used to label images that are taken by machines, both kind of LiDAR, radar, and visual range images. If you have engineers do it, engineers are so biased, right? They know that, for example, straight edges or certain things mean man-made objects. They have all this knowledge in them that allows them to sometimes dismiss it as in, oh, the machine should be able to detect this. Whereas a human being, ultimately, you're trying to emulate how a human being is going to drive this, a non-engineer necessarily, who is kind of doing that driving task. And that emulation requires you to actually deal with it in the way human natural drivers do it, not with the bias of a computer scientist or an engineer doing the labeling for you. So in many cases, it's ironic. The less expertise you have, the more effective you have, but you have to be trained, of course. You have to be told, here's what we're looking for. We're not looking for everything, right? And get these guidelines.
Well, you have to be trained in the task, but you also want to be observant, because
exactly.
Being able to observe and be curious is what we just cannot get the machines to. We grab them by the metaphorical lapels and they just won't. They just won't do it. You know, they're just not curious or observant. You know, Robert made a similar comment, because he said, either in his book or when we talked to him, he said that the thing about somebody that spends months data annotating is that, you know, it's a very structured environment. There's bounding boxes or what have you. There's a very structured task. But he said you want to also chat with folks like that offline in an unstructured way and just say, what have you noticed that's odd? What have you noticed that's strange? What are we not incorporating into the process? And he described that as a real, gold mine for data.
And better yet, Keith, you want to build tools that captures that intuitive and informal kind of unstructured knowledge on a systematic basis. And by the way, that science and that art is missing, right? This is why I'm so excited about experiential AI. That's so crucial for getting quality learning data, yet we don't even know how to systematically get all that information. So you're right.
You know what that resonates with in my own, personal experience is I've done a lot of survey analysis over the years, and as I'm sure you know, it's a nightmare. No one wants to collect data through survey data unless that's the only way to collect data. It's always a source of data of last resort. But when you do that, you realize that no matter how hard you try to ask structured questions in a survey, you have to have some open-ended, because despite your best efforts, there's going to be some information that you would lose if you didn't allow that alternative way.
And by the way, what you are describing is the intuitive way to describe what we call the bias, the built-in bias in the data that is causing so many issues. I mean, another area of focus for us, both at Open Insights and at the Institute for Experiential AI, is responsible and ethical AI. And part of that is dealing with this bias in the data and understanding that anytime you encode data in a structured manner, you are implicitly putting huge amounts of bias that will show themselves in very ugly ways down the road, in ways that you can't predict. And that's because you're giving the algorithm a projected image of the world, not kind of enough context and not enough knowledge. And that's why, as you said, that free-form feedback, that ability to capture it and understand it, is invaluable to overcome that.
That's very interesting indeed. I want to acknowledge that we're getting a couple of very cool questions coming in. Okay. But one more aspect of that, and this came up in conversation at some point, some time ago. But I think most folks, in fact, especially, potential data scientists in their 20s, probably barely remember when we didn't have Google search, but clearly there was a day when that wasn't around. So since we're so used to it and we use it every day, we kind of assume that that's done now, that's finished. But you were mentioning in conversation, there are thousands of individuals behind the scenes that are supporting that. Could you comment on a little bit, that even stuff that we think of as being completely figured out, isn't?
Yeah, absolutely. I'll tell you even why it's even more necessary to have human intervention in that scenario that everybody thinks is automated. Well, first of all, today nobody really understands how a search engine ranks pages. It's the output of a machine learning algorithm, and it's actually an example of how a change in that algorithm could ruin industries, could make or break entire economic sectors that rely on traffic coming to them by being found on search, right? So it has huge consequences. Now, one of the ways that Google early on kind of realized, hey, if I collected automatic feedback from people, click-throughs, right? I will actually now collect, and by the way, they had the team, just like Yahoo, just like Microsoft, 20, 30,000 editorial folks who are sitting in the back saying, no, move this up, move this down, etc. So number one, you can't get that move this up, move this down, remove this, move this from the 20th page to here, from click-through data to begin with, right? Just by observing passively. Number two is, and you need a human intervention for that. Number two is, if you follow the click-through data, it will take you down really bad places. Meaning, you show people the top results, they click on the top results, they reinforce the top results, and if that top result is wrong, it just gets reinforced as the wrong result to always show and to promote, right? So it's a self-fulfilling prophecy that you need to break out of. And that is the problem with kind of doing passive click-through data. What you want here, and as we all know, search deals with this big problem called the long tail. Many, there's some search queries that are like, basically the majority of queries are in those common queries. And then there's a huge amount of queries that have very few users, right? And to get those results, you can't rely purely on click-throughs. You do some of the time, but you need to augment it with human judgment. And that's where that comes in. And that comes in many, many areas, including, by the way, in autonomous driving, where if that will never be solved. At least the way we are trying to solve it today by pure training. You cannot anticipate every possible image in the world and what the outcome should be in that image. You have to have something that we call in humans transfer learning that we haven't figured out how to make machines do effectively yet.
But
we always need humans to label these things.
How do you have a human in the loop in real time, though, down the road when we're hands off the steering wheel?
Great question. That's why it's my personal belief that the problem of autonomous driving is solved and will be solved for slow-moving vehicles. I do not believe that in the near term we will see solutions for fast-moving vehicles. And by fast-moving vehicles, I mean something like an Uber, running around the city at a reasonably high speed. What do I mean by slow-moving vehicles? Think of your garbage truck, right? Its task is to drive down the street, recognize where the garbage cans are, hit them with the robotic arm, put them back safely, etc. Let's say that garbage truck sees something new, right? It can absolutely turn on its hazard lights and stop and call for help and wait for effectively a human to teleport in, look at the image and say, no, that's just a balloon, or that's a weird, I don't know, jelly-looking spot that I've never seen before, but it's okay, or that's oil, or that's something combustible, or that's a baby, or that's a cat, right? So that ability to stop and call for help is essential, and I actually think that many of these slow-moving vehicles will work. They already work in hospitals, they already work in stores, they already work in factories, right? And they will work on the streets. But you have to have that condition, because we haven't yet figured out how to solve that problem doing it the way a human does. If you, God forbid, have a near accident or an incident, for whatever reason, your brain is capable of saying, well, all similar problems to this one, I know what to do now, right? I know what the dangers are. That ability to generalize and cross to other tasks does not exist with machines today. And what you have to do is show them every instance of where that similar problem, like somebody shows up out of the left lane, makes a weird turn, U-turn, and disappears. Well, you gotta see it in every possible context for them to reliably be able to parse it in the future. Whereas you kind of get the idea. Hey, some weirdos, just show up, make a weird U-turn, and disappear. It's okay. And that can happen on a mountain. It can happen in a city. It can happen in a country road. It can happen on a dirt road. And it all works in your brain. It doesn't work for the machine.
So really what you're describing is that the exception processing is going to pose a problem for, some time. And obviously there's a lot of folks in the industry that would be somewhere more optimistic than you on that continuum. But that resonates with someone that is forever dealing with exception processing, no matter how good any model I build is.
Trucks moving at fast speed on a highway in a highly controlled environment where you don't allow random access to that highway, meaning it's got boundaries and nobody can get in except at exits, that is doable. That is completely solvable. The problem is with all of these deliveries is that last mile. You got to get off the highway and you got to navigate your way somewhere. So we will probably shift modes here. We'll probably do the long haul driving, at high speed on restricted highways that are very well controlled by machines. But then that kind of last mile needs a lot of human intervention.
Kai-Fu Lee, the famous researcher and investor, made exactly that point about trucking, and felt that there are some differences between Chinese culture and the culture of Silicon Valley, and that sometimes perhaps in Silicon Valley we get a little bit too ambitious when you could go to market with something less ambitious and more practical. That was a point that expanded upon in his book a couple of years ago. I want to get to audience questions. I have a couple of loose ends that I want to circle back to, but I want to acknowledge the questions and get to them. One in particular really resonates with me, and I think you're going to like it too. So Harold is watching and asked. I think it's Harold. It's the. I may have the name wrong on this question. I apologize if I do. But someone's commented that it seems that we want data scientists that have almost sociology or a psychology background to better understand data and these issues. A part of me is desperate to answer this question myself, but I want to give you a chance to do so, because I'm sure that you're going to like this question.
Yeah, look, I mean, it's a great point, and I think it actually highlights two different dimensions that we need in data scientists. Number one is we need that experiential kind of background that basically says they had the chance to kind of get exposed to the limitations of the algorithms, their silliness, their stupidity, and the huge dependence on data and all of that, the art of data science. The other side is the domain expertise or knowledge, right? So depending on what you're, so to me, data scientists are going to emerge in two different areas. You will get the experienced data scientists who are kind of general knowledge, but have been exposed to enough areas with supervised apprenticeship to know and appreciate, how to deal with the limitations of the algorithms and data. And then there'll be the data scientists who are domain experts, who are subject matter experts. Those are absolutely necessary. So if your applications has to do with social networks or sociology or understanding kind of socioeconomic data, etc., then it helps hugely to have a data scientist who has expertise in that area and understands the nuances of the field itself. Similarly, if you're trying to interpret images of collisions of objects in a collider that are happening at huge speeds and produce weird stuff. I've been exposed to one where we had to recognize small volcanoes on Venus using synthetic aperture radar, where the images don't look anything like what you expect to see with the naked eye. But, the scientists were pretty good at picking out where these small volcanoes are. There was about 1 million of them on Venus. We could not have done it without those kind of domain expertise of somebody who thought about the problem, understands what a volcano looks like, how it might look like in a radar, and what kind of patterns they look for and how they vary.
Yeah, what it reminds me of is some of the comments that Gary Marcus has made. You're probably familiar with him. He's a cognitive scientist, and he's I think he's more controversial than he needs to be, because he comes off initially as being pessimistic about AI, but he's just trying to compare the state of the art with what brains can do. And his conclusion is that where we are right now is coming up short. But if you look at this through the lens of cognitive science, you can spot where we're weak in the technology so far. You always mention common sense is one of the ways that you phrase it.
Yeah, no, common sense reasoning is something we haven't been able to emulate, but I'll go even stronger, and I fully agree with him. We have not yet solved any problem, and I will underline any 3 times. We have not solved any problem in AI the way that a human brain solves it. We have found shortcuts, we have found ways around it, we have found ways to estimate it, we have regressed our ways around it. Sometimes we use barcodes to recognize objects in images. Humans don't use barcodes, but barcodes are a very reliable ways to identify objects. So that is a stronger statement. The advances in algorithms explaining how human intelligence or even animal intelligence works have been extremely limited and near nil in many fields. So I share the pessimism there. It shouldn't discourage us. I mean, it takes a long time to understand these complex phenomena. It took humanity, thousands of years to reach the stage of understanding, nuclear physics and quantum physics. So it's not, the problem of intelligence is equally hard and will take us a long time. In the meantime, we can have tools that help us kind of reason, navigate the terrain, the space, the problems, and come up with useful, very narrow engineering and business solutions.
I agree with the notion that just recognizing that the technology can't do everything on its own yet is not pessimism. It's just helping us pave the path forward. So
it's reality. It's reality.
Yeah. Just recognizing the task before us, right?
Yeah.
So earlier we were talking about these two different kinds of expertise, or how counterintuitively, or perhaps counterintuitively, expertise can interfere with perception in some ways, right? So we talked about expertise in that way. There's a really interesting audience question asked by Harold about business knowledge. And this is someone that's been a consultant most of my career. This comes up all the time. I'll sometimes be asked by a potential client, how many times have you tackled a particular banking issue that is identical to the issue beforehand, right? Could you comment a little bit about the expertise that comes from, like, the kind of folks that you're going to be attracting to the Northeastern program, that comes from tackling disparate problems? For instance, you started at JPL, where you were surrounded by, somewhat more of an academic type crowd, obviously also tackling practical problems, but then also a lot of experience in Silicon Valley. So that obviously gives you a perspective that you wouldn't have if you had spent your whole career at one company. How do you weigh these two different kinds of expertise, the kind of expertise that comes from tackling diverse projects, and the kind of expertise that the question is getting at, which obviously is important, which is specific to predictive maintenance or manufacturing or banking or radiology?
Yeah, so this is a very tough question. There's no obvious answer to it, but a lot of it is an art. I mean, I'll go further. I mean, Open Insights itself, I mean, I formed it after I left Yahoo, my role there as Chief Data Officer. And really, the reason I formed it, and Microsoft, in fact, Satya Nadella was the first client of the new company, Open Insights. But the reason we formed it was to democratize this notion of, data is so darn essential to solving a lot of these problems, because we have a lot of data and we have very few algorithms, right? So the trick here, it's a nice mixture. It's a majority mixture of data, and there's a whole story on data, and we can spend a whole program discussing how to get data right, at the right granularity, with the right quality, with the right management, so that it can feed algorithms and not just human analytic consumption. So call it 90% or 95% data. And then there is that small, tiny percent, which is kind of algorithms. So you need somebody who understands them. And then there's this other part, which is so essential to making sense out of the data and making sense out of what the algorithms do, which is the domain knowledge, which is that subject matter expertise and understanding it. So the way Open Insights works, and we work a lot in financial services, insurance, banking, telcos, a lot with retailers, big retailers like Walmart, etc. A lot in with private equity firms that take us to all their portfolio companies, which are in many, many different areas. And the way we make things work is we build a team who is both kind of open-minded, and a good part of them is not just engineers, but business savvy engineers who kind of understand that, hey, a lot of the knowledge is sitting in the heads of these subject matter experts, and it's about figuring out how to unlock it most effectively by partnering with them. And that's how we address it, is we have people who are very well trained in the learning and in the data, which are very, very both very important fields. I would say even data is more important than learning. And then the second part is that open-mindedness and the ability to kind of figure out how to maximize the value of subject matter expertise and leverage it correctly. Without it, without me working with astronomers at Caltech, or with planetary geologists at Brown University, or with atmospheric scientists at UCLA, and on the examples go in data science analysis. Similarly in business with retailers, and you could come up with the world's fanciest recommendation algorithm, but it takes a retailer to tell you, hey, if I'm trying to sell pants, right, and your statistics is telling me, hey, Keith just added this pair of pants to their basket, right? Now I should show them more pants. The algorithm, the statistics say show Keith more pants. The retailer will say to you, do not unsell those pants, because the minute you start showing them more pants, they're gonna change their mind, say, is there something wrong with my choice? What did I do wrong, etc.? And then you lose the whole sale. What you need to show then is the complementary stuff. Statistics can't give you that. And the merging of the power of statistics with the power of understanding the domain and the constraints, and that the business, they need to move belts this month, and they need to move, belly buttons the other month, etc. You're not going to get that from the statistics. You have to merge the domain knowledge, which is so essential, with the data, which is also so essential, with the ability to find the relevant predictions.
Yeah, a well-known, I think, example of what you're describing is that years ago, when Amazon was much younger, you would look at something like a big screen TV or a cinema display, and it would recommend a second big screen TV to go with it. And then, obviously they're a top-notch company. They figured that this didn't make sense.
Right.
So now it's people that viewed this ultimately bought that, right? They're trying to navigate that. We're both wearing sport coats. So I imagine that if we were looking for a sport coat on a particular day, we probably don't plan on buying 3 of them. We probably want to be recommended a tie.
Yeah.
That question was trying to get at Harold's question about the specific business. And I want to invite Harold to do a follow-up if there was an aspect of that we haven't covered. And I apologize for the being tongue-tied about the names. When I glanced over at the show notes, we were in the middle of a copy and paste maneuver, and I glanced over at the wrong moment. So I want to get to one of Faisal's questions. This feels nostalgic to me. I don't know if you're going to have the same reaction, but I'm just going to ask the question and then add a comment and let you respond. Our thoughts on no-code platforms such as a CERN and Uncork. And my brief comment is, I've been doing this since the late 90s. You have a substantial, head start on me. So you would remember this period too, where we first started to get these flowchart looking platforms, like Enterprise Miner and Clementine, which would now be an IBM product. And then absolutely the pendulum swung towards technologies like R and Python. And we're playing to potentially a small fraction of our audience here by getting into data science technology here. But no code is all the rage. And when I read about it, everybody makes it sound like it's new. And it doesn't strike me as new at all. What's your take on no code?
Look, no code is extremely useful in areas where you know exactly what the task needs to be, how it is. If I'm trying to connect to a data source, a complicated database or some legacy database, and I've done this 1,000 times before, there's no point in kind of, recoding that whole connection, and one box that figures out how to do it and gets smarter over time could work. But those are examples of that. And by the way, that's not guaranteed to work, because when it doesn't work, then you're stuck and you don't know why the heck it's not working, right? Yeah. Because it's no code and you don't have access. So for very well understood tasks, I think no code is very, very appropriate. For most tasks, you need a mix of both. So the art here is, can you factor it into a bunch of very routine tasks, and then leave the flexibilities of kind of customization and going into it and injecting some innovation for the tasks that are not as well figured out, right? So, for example, writing, and you see this, R itself is a library of routines, right? People have figured out the routines. We call them routine because we understand exactly what they do. And we say, okay, you know what? There's no point in me writing something that computes the average and standard deviation. There's no point in me computing an algorithm or writing an algorithm that does the logistic regression or the best fit or optimizes to this metric or to another. So that can be a black box. You may call it a library. You may call it no code. You may give it a graphical box and drag and drop it. But there's also the logic of putting things together and doing the problem solving. And that one is much harder to get with no code. platform.
Yeah, I have a very brief story that I can't resist relaying, and it's the history of the first predictive analytics workbench that had that style, that had that flowchart style. And what happened is Colin Shear and his colleagues, this was the Clementine product, a name that most people would not recognize now, but at the beginning of their client engagements, they would go to the whiteboard and they would draw all the data integration that they had to do. And most of it was tedious or even arguably kind of boring. It was the same thing over and over again. And at a certain point, apparently out of frustration in the meeting, they said, I wish we could just take a picture of the whiteboard and be done, right? Because we've done this 100 times.
Right.
So that's what they did, is they tried to design an interface that looked like their whiteboarding that they would do to do their data integration. So we have to start winding down, but I want to ask you, I can only give you about a minute or two to respond. It's a big topic, but we talked a bit about IADS and how we met in KDD and how, data science needs this structure. I want to ask a question that's kind of related to that. You were quite early in your career when you helped organize the first KDD conference, which is, kind of how we collaborated on last year's thing. And I'm very fond of that conference. I've been to it a number of times. I'm sure you've been many more times than I have. How did that all happen at that stage in your career? I mean, that was, you were winding down your grad school career, or possibly still in it, or just out. I guess you were just out of grad school when you co-chaired.
Oh yeah, no, I was out of grad school and working at JPL and transitioning to Microsoft. But I will give credit to my colleague Gregory Piatetsky-Shapiro. When I was a student, he contacted me to come do an internship with him at GTE Labs. But part of that interaction, I was working at General Motors Research Labs for a summer, and this was when I was first starting my PhD topic on machine learning of classification trees, decision trees. And he held this workshop at IJCAI, the International Joint Conference on AI. That was in 1988, I think, or 89. And that was kind of the first workshop. And then he ran these workshops, and it was just a gathering of people, and we called it KDD at the time, where if you fast forward to 1995, the interest and the audience for this workshop had grown so big. We were holding it at AAAI conference and IJCAI, that basically we decided we're going to make it its own conference. And that was the first one that I co-chaired, in fact, with my mentor at General Motors Research Lab, Ramasamy Utrusamy. And it was a huge success. So 1995, Montreal, I still remember that. I co-chaired the first KDD conference. And since then, it has grown into an attendance of thousands, and it has grown to be probably one of the most selective, tough to publish in, and useful conferences covering data science, machine learning, and knowledge discovery in databases in general.
Well, it's a remarkable conference, and it's been more than 25 years now, still a very successful one. And of course, around that same time, you wrote that very influential article also with Gregory on the KDD process. Yep. I actually did a poll about that. I said, which of these 4 articles that have been around for many years should still be kind of in the canon, for young data scientists to read. That was an interesting poll to do. Okay, we have to wrap up. I want to thank you so much, Usama. I hope I've done a reasonable job juggling both the audience questions and the prepared questions that we had, because we clearly could have gone 2 hours today.
I think we covered a lot of ground. Thank you for doing this. And we didn't cover the topic of, how did the chief data officer come about as a joke in the beginning, but we'll do that in a future event, I'm sure.
You know what we could even do is have a brief 5-minute exchange with that story and use it to promote the recording, because we want people to be looking out for that. Be looking for announcements of various kinds. We always do a blog post summarizing this, which would be tied to the recording. I'm sure that Usama and his feed will be talking about it as well, because I hope that we've covered enough powerful information that you actually want to check this out a second time. I frequently find myself enjoying watching these a second time.
And to the audience and to you, Keith, we are more than happy. I'll work with my team to answer any questions that come after the fact, or that we haven't gotten a chance to answer in today's show on the social media, on LinkedIn especially. So Keep those questions coming, and our commitment is we will answer them and post them with reference to this. I normally kind of build a bigger blog by answering questions coming out of an event like this one. Thank you.
That is very generous with you, and I will work with our team internally to try to find the right forum for doing that. It could be a LinkedIn post with a commentary below. We'll brainstorm about the best ways to do that. And I want to announce to everybody that we're doing the July event a little early, so it's only 3 weeks away. We're going to be chatting with Jonathan Reichendahl, founder of Human Future, but also author of Smart Cities for Dummies, which I've been reading for the last several weeks, and I really, really enjoy that book. And Jonathan is just going to be a really fun guest to have. And that's already available in the Cloud Factory events page, which I'm sure is going to be in the comments here, to go ahead and sign up for that now. So be looking for the replay. Please take Usama up on this offer to continue to interact with him. And I had a fabulous time. I hope everybody else did. And we'll be signing off for now. Thanks again, Usama. Cheers.
Thank you. Bye-bye.